Hello students, welcome to our YouTube channel Empower Education. I am your chemistry teacher and your guide Tejashree. Students, by the title you know that what we are going to discuss today. We are going to discuss about materials. What kind of materials? Metals and non-metals. Student, you know that everything around us has metals and non-metals. So what we are going to discuss in today's video session? We are going to cover various important points related with this chapter in today's video session. So are you all excited everybody? So let's start. Okay, first of all we are going to see what are the important concepts which we are going to learn in today's video session. Okay, so let's start. Okay, what we are going to learn. So let me show you. Here are some points that we are going to discuss in today's video session. We are going to discuss about the metal, their physical properties. We are going to discuss about non-metals, their physical properties. We are going to discuss about chemical properties of metals, as well as we are going to discuss about the reaction, okay, in which metals are involved. So what kind of reaction, like what will happen if metals react with acid? What will happen if metals react with base? So yes, and yes, one of the important point, how metals react with non-metals. So that points we are going to cover in today's video session. So let's start from the basic information, because I always say that basic concept is very necessary to understand any concept, right students? So let's start with metals. I hope you are going to join my live session and this will very helpful to you, definitely. And yes, in simple language we are going to understand all the concepts, right, related with metals and non-metals. So let's start with our first point everybody. So that is metals. So on your screen you can see some objects which are obviously made up of metals. So what are metals? Before going to start the actual point, students, you know that our periodic table contains totally 118 elements, and out of that 118 elements, 90 elements having the metallic characters. So the number is very big, as you can see. So out of 118 elements, 90 elements are metal in nature. Especially the S block from the periodic table contains metals. So basically, metals are the chemical elements which radially lose valence electrons. So what is valence electron over here, student? Valence electrons are those electrons which are present in the outermost orbit of any element, and that particularly electrons known as valence electron. So yes, these metals are those chemical elements which readily lose electrons. And what is the next step after losing the electrons? They gain the positive ions which are known as cations. So here one word is very important, which is ionic bond. We are going to discuss on that later, but yes, cations and anions, this is very important point over here. What are cations, students? Cations are the ions which are positive in nature, while anions are those ions which are negative in nature. Positive ions, cations, and negative ions, anions. So basically what actually metals do, they readily lose their valence electron and gain positive ions which are cations. So yes, you know the basic examples of metals: iron, copper, aluminium, right? These are some examples of metals that you observe in your day-to-day life. Am I right, student? So let's disclose what is actually metals. So I have told you the basic information regarding with metals. So let's see Yes. Here you can see on your screen. Metals are described as chemical elements that I have already told you, right? That readily lose valence electrons to form positive ions. That positive ions are nothing but what? Cations, right? So here are some examples like aluminium, copper, iron, tin, gold. Right, students? So these are some examples of metals. As I have told you the extra information in periodic table, out of 118 elements, 90 elements are metal in nature. So the number is very big. So we have to understand what are the physical properties of metals. So let's discuss about that. Okay. Here we are going to discuss what are the physical properties of metals. By the appearance, physical properties are nothing but what? By the appearance, you can assume, yes, these are the physical properties of the metal particular over here, right? So in this way, we can easily say by the appearance, what are the physical properties of any substance. So here we are going to discuss about what are the physical properties of metals. So I am going to disclose one by one the physical property. Then I am going to give you the extra information regarding with the physical properties of metals. Definitely we are going to see that. Here the first property. Yeah. So on your screen you can see that metals are generally hard and they have high tensile strength. Means what is mean by high tensile strength? We can give more stress to the metal. And yes, they are hard in nature. But yes, student, there are some exceptional cases also. Later on, we are going to discuss on that. But yes, this is the general characteristic. First one, metals are generally hard and they have high tensile strength. Like take one example, iron, right, which is hard in nature. You cannot easily break that substance, right? So yes, this is the first basic characteristic of metal. Let's discuss about the other characteristics. Generally, metals are solid at room temperature. The appearance of metals, they are solid in nature, everybody. So, sonorous. So, what is sonorous? So, basically, students, metals can produce sound. Okay, pleasant sound. Sonorous means what? Pleasant sound. So, they can produce sound when we heat metals to any material. So that is one of the characteristic or property of metals. Next one, good conductors of heat and electricity, that you have been studied from your standard 5th, right? Metals are generally good conductors of heat and electricity. We use pan, right, in our kitchen. Why we use pan? You know that pan is made up of what? It is made up of metal like iron, right? So generally metals are the good conductors of heat and electricity. How electricity? That we are going to discuss one by one. So see, malleable, they are malleable, they are ductile in nature. So what malleable? That means we can beaten up the metal and we can convert them into the thin shades. That is the special characteristic of metal, everybody. Ductile. What is the meaning of ductile? So basically ductile means what? We can shapen up metal as we want. We can convert them into the thin wires. And take one example, copper, right? You can see copper in wires that you use in your house, right? So as you know that ductile, malleable, these are the general characteristics of metals. Generally metals have high boiling and melting point. And metal are lustrous in nature. They have a shiny appearance. Take one example of gold, silver, right? Who don't love gold? Everybody love gold, right? And they have shiny appearance. Basically, metals have shiny appearance. So that is lustrous in nature. So as we have discussed many general characteristics of metals, these are the basic characteristics, basic properties of metals. Mostly these are in grey or silverish in color. Metals, okay. Mostly metals are in grey or silverish in color. there are exceptional cases also. Yes, obviously you know that gold and copper, these are also metal, but they are not appear as silver or grey in color, right? So the color is different for that. So as I have told you, there are some exceptional cases also. What kind of exceptions are present in physical properties of metals? First one, when we talk about mercury, everybody, you know that mercury is a metal in nature. But do you know that, student, as I have told you, metals are generally solid in nature, right? But mercury is the exceptional case for that characteristic. Because mercury, though it is a metal, it will appear in liquid nature. It has a liquid nature. Its appearance is liquid. So it is one exceptional case, that is the general characteristic, general basic information that you know, right? Same, this first characteristic or first property of metal, which is the most general property of metal. What is that? Generally metals are hard in nature. But students, do you know that alkali metals? What are alkali metals, everybody? Alkali metals, S block elements are divided into two groups. First A group, alkali metal. Second A group, alkaline earth metals. So basically they are metallic in nature. Okay. So alkali metals like lithium, sodium, potassium, we can cut them by using knife. Is it an exceptional case, everybody? Yes. So as you know that generally metals are solid or hard in nature, but this is the exceptional case, right? Sodium, potassium, lithium, we can cut them by using knife. So that is one exceptional case. Metals like cesium and gallium, okay, they have generally very low boiling point, sorry, melting point, not boiling point, because in case of metals there are melting point, because generally they are in solid state, right? So the gallium or what we can say cesium, these two metals, they have very low melting point. So my dear students, these are some exceptional case, exceptional physical properties of metals. So yes, I think this is sufficient for you to understand what is metal. Metal are the chemical elements. They generally lose electrons to form to gain positive ions. Positive ions are nothing but what? Cations, right? We have discussed the general characteristics of metals, right? Solid, they are solid in nature at room temperature. Exceptional case is mercury, as you know, that is given on your screen. They are hard, right? They have high tensile strength, that we have studied. Malleable, they are malleable means what? We can convert them into thin sheets. They are ductile in nature. We can convert metals into thin wire. Sonorous, they can produce pleasant sound. When we hit metals, they can produce sound, right? And metals are good conductors of heat and electricity. They have high boiling and melting point. Some exceptional cases are there. Generally, metals form in grey or silver color. So yes, student, this is all about the physical properties of metals, right? Now let's move on to the non-metals, as we have taken lots of information regarding with metals and the physical properties. So moving on to the next point, let's discuss about the non-metals. So basically non-metals possess exact opposite properties of metals. As we have studied, metal lose electrons to form positive ions. Here the exact opposite situation. Non-metals are also the chemical elements which accept or gain electrons to form anion. Anion means what? Having negative charge, everybody. So yes, this is the basic information regarding with non-metals. Generally, student, in their outermost orbit, they contain number of electrons like 4, 5, 6, 7. Why? Because they have to accept electrons, right? So basically in their outermost orbit there are electrons like 4 electrons, 5, 6, 7 in this case only you can observe, right? So what are the examples of non-metals? Carbon, boron, oxygen, everywhere there is a non-metal. as we have discussed, metals and non-metals, you can observe it everywhere, right? So yes, this is the basic information regarding with non-metal. I am hoping that you are going to learn the basic things regarding with metals and non-metals. Okay, so let me disclose what is actually related with non-metals. So here is the information that we have discussed. Okay. Yes, what I have given to you. Non-metals are those elements which do not exhibit the properties of metals, means exact opposite properties they contain, right? Opposite of what? Opposite of metal. Example, carbon, boron, nitrogen, oxygen, right? So this is the example, these are the examples of non-metal. Now let's discuss about what are the physical properties of non-metals. And yes, everybody, there are also some exceptional cases, yes, that we are going to discuss regarding with non-metals. But first of all, let's discuss what are the physical properties of non-metals. Yeah, as you can see over here, they can be present in any state, like they can be solid, they can be liquid, they can be gaseous at room temperature. So as you know that metals are exactly solid in nature, but here non-metals can available in any state, like they can appear as solid, they can appear as liquid, they can appear as gas at room temperature. Okay, everybody, they are brittle in nature. Brittle means what? They can crack easily, they can break easily. Okay, so that is brittleness in nature. They are non-malleable. We cannot convert any non-metal into the thin sheet, so that is non-malleable. They are non-ductile. We cannot convert any non-metal into thin wire, so that is the another property of non-metal. As you are observing these properties, students, you can easily differentiate between metals and non-metals. So you can use these points for the differentiation between metals and non-metals. Am I right? Is it easy, everybody? Yes, definitely it is easy. They are non-sonorous. They cannot produce any sound, right? Non-metals cannot produce any sound. So they are non-sonorous. Bare conductors of heat and electricity. As I have told you, there are some exceptional cases also, like if we take one example, iodine. Okay, so obviously you know that non-metals are not having any kind of shine, right? They don't appear as a shiny substances, right? So here one exceptional case over here in non-metals, iodine. Iodine, though it is a non-metal, but it has a shiny appearance. So that is one exceptional case over here. Though it is a non-metal in nature, but it has a shiny appearance. Second one, graphite and diamond, everybody. You know that graphite and diamond are what? Graphite and diamond are the two different most common forms of carbon. Carbon is what? Carbon is solid non-metal element. So graphite and diamond, these are two forms of what? Carbon, which is a non-metal. But do you know that, student, graphite is a good conductor of electricity. You know that generally non-metals are bad conductors of heat and electricity. So, but there is one exceptional case over here, that is graphite. Graphite is a good conductor of electricity. Okay, it is non-metallic in nature because it is the common form of carbon that you now studied, right? Second one, diamond. You know that diamond is the most hardest substance which is present in world, right? But that diamond is also a good conductor of heat, and students, its melting point is very much high. Generally, boiling or melting point of non-metals are very low. But here one exceptional case, which is diamond. Diamond has highest melting point. Okay, so yes, these are some exceptional cases regarding with the physical properties of non-metal. So what we have discussed still now, we have discussed about what are the metals, what is the basic information regarding with metal, what is the basic information regarding with non-metal. We have studied what are the physical properties of metals and non-metals. Student, one question will be asked in your exam like differentiate between metals and non-metals. Now I have given you one hint how you are going to differentiate between metals and non-metals. You have to just use that physical properties and you can see that if you compare both the properties are different from each other, right? So basically non-metals possess exactly opposite characteristics of metals, right? So yes, we have studied about the exceptional cases also. I hope you are going to understand, you are going to learn the basic things, right? So now let's find out who has joined my live chat. Everybody, welcome to our YouTube channel. Those who are new, those who are listening me right now, please go and watch our other videos also. Definitely you will find it very helpful. Okay, now we have discussed about the physical properties of non-metals. What is the next point that we are going to discuss? So the next point for you, everybody, yes, one of the very important point and one of the very important hot content which will be asked in your exam. So what are the chemical properties of metals? Here are some points that we are going to discuss one by one, everybody. So as you can see over here, first one, displacement reaction. What are displacement reaction, ma'am? We don't know. Yes, definitely we are going to see what are the displacement reaction over here. Can we discuss one by one? Let me first tell you all the 4 points and then we are going to discuss one by one. Metals reaction with oxygen. Can metal react with oxygen? What will happen after that reaction? That we are going to see over here. Basic oxides of metals. What are the basic oxides of metal? That we are going to discuss over here. Amphoteric oxides of metals. So what are amphoteric oxides, ma'am? These two words, basic oxide and amphoteric oxides, are very difficult to understand. Don't worry, I will definitely help you for that. But let's start one by one. First of all, we are going to discuss about what are the displacement reaction. So student, displacement reaction is nothing but what? It is a chemical reaction in which a more reactive element, or we can say it as metal, displaces a less reactive metal or element. So for that, to understand that concept, obviously I am going to give you one example, and from that example you will find out this concept very easy. So yes, definitely this is one of the important chemical property of metals. Okay, so here I am going to write it down, everybody, displacement reaction. Yes, obviously we are going to study now what are the chemical properties of metals. Okay, so displacement reaction, let me write over here. Okay, everybody, now I have one example for you. When zinc solid, that represent the state, yes, it is metal. When zinc, hello Omi, I hope you are enjoying my live session. If you have any queries, you can ask me. Yes, so let's moving on to the next point over here. When zinc reacts with copper sulfate, it is aqueous. Okay, what will actually happen? Now look at these two metals. Here you can observe two metals. First one zinc and second one is copper. Okay, so zinc is more reactive element, or we can say it as zinc is more reactive metal than copper. So we are going to learn about the reactivity order of metals also. This point is very important. If you learn this point over here, definitely lifetime you will use that point. Okay, because in 9th standard, in 10th standard, 11, 12, you can use this reactivity order. So definitely we are going to discuss on that. So here zinc is more reactive than copper. So displacement reaction, in that displacement reaction, zinc replaces copper from its aqueous solution. So what will the product over here? We will get zinc sulfate and copper is now displaced. Yes. So this is the displacement reaction. I hope you understood what is the displacement reaction, everybody. So this is one of the important chemical property regarding with its reactivity. Okay, how metals react in any kind of chemical reaction. So for that purpose, reactivity order is very important. So regarding with that property, this property is very important. Displacement reaction, again I am repeating, those reaction in which more reactive element or metal displaces less reactive metal or element. That reaction is known as displacement reaction. And here is one example for you. I hope you understood the concept. Next, moving on to the next point, metals reaction with oxygen. I am going to give you some more examples to understand this concept. Okay, first of all, basically what actually happened, let me clear first these things so that I will write for you over here. Yes. So now we are going to discuss about this point, which is very important. When metal reacts with oxygen, so I will write over here, metal plus oxygen, there is a formation of metal hydroxide. Okay, sorry, metal oxide, not hydroxide, metal oxide. So this is the basic reaction. When any metal reacts with oxygen, there is a formation of metal oxide. Okay, now there are some other metals like sodium and potassium. You know that, student? We keep these metals in, we immerse these metals in kerosene oil. Why this is so? Because these metals show vigorous reaction with air and they can catch fire if we keep these metals open. If we don't put these metals into kerosene oil, they will catch fire. They will show the vigorous reaction. So sodium, metals like sodium and potassium. Okay. So this is the next part regarding with metals reaction with oxygen. But yes, there are some other metals which do not show any kind of reaction with oxygen or air. Silver, gold, platinum. These are the elements. These are the basically these are the metals which do not show any kind of reaction with metal. Magnesium, aluminium, zinc, lead, these are the metals which show slow reaction with oxygen or air and they form a protective layer around them to prevent them for corrosion. So yes, is it interesting? Yes, definitely. So as I have give you some list, you can understand that what metals show what kind of reaction with oxygen. Some metals, like you can see the reaction when metal reacts with oxygen, or we can say it as air, definitely it will give you metal oxide. This is the first basic reaction when metals react with oxygen or air. Second one, metals like gold, silver, platinum, these are the metals which do not show any kind of reaction with air. Next, metals like magnesium, aluminium, zinc, lead, these are the metals which show slow reaction with oxygen and they form a protective layer around them to protect them from what? From corrosion. And yes, some metals show very vigorous reaction. What kind of metals? Sodium and potassium. We have to keep them into the kerosene oil. Why? If we do not, if we didn't do this, so what will happen? They will catch fire, everybody. So this is the vigorous reaction. So yes, we have discussed about the displacement reaction. We have discussed about metals reaction with oxygen, right? Or we can say it as air. So now what are the basic oxides and what are the amphoteric oxides of metals? So that we are going to discuss. For that, let me clear the slide, okay, for you. Now we are going to discuss about the third point. This one. Yeah. Basic oxide. Generally basic oxide, how they form? Students, metal oxide, when we dissolve metal oxide in water, there is a formation of alkali. And this kind of the metals or this kind of reaction is known as basic oxide. Means basically they will get converted into alkali. Alkali means what? Base. So can we take one example for to learn this concept? Yes, definitely. Here I will take you one example. I will give you one example. This is potassium oxide. When potassium oxide reacts with water, or if we dissolve potassium oxide in water, this is liquid, this is solid. What will happen over here? There is a formation of 2KOH. Means you from this you can see that the metal oxide, okay, this is metal oxide, when it dissolved in water, there is a formation of what? Basic oxide. So this is basic in nature. So yes, this is nothing but what? Basic oxides of metals. So any metal, when we dissolve it in water, that will convert any metal oxide, okay. Any metal oxide, when we dissolve it in water, it will get converted into what? It will get converted into what? Basic, mostly in alkali. So this is alkali or base, right? So yes, this is nothing but what? Basic oxides of metal. Now what is amphoteric oxides of metal? Both the concept kind of they show similarity, okay. Amphoteric oxide and basic oxide. Generally what will happen in amphoteric oxide of metals? Metal oxides can react with both acid and base, okay. And yes, there is a formation, after that reaction there is a formation of salt and hydrogen, salt and water, not hydrogen, salt and water, and that kind of reaction is known as amphoteric oxide of metals. Let's discuss about that, student. Yes, let me clear this. Now we are going to take one example, and that metal will react with acid as well as base, and we are going to see what will happen over there. So basically when metal oxide react with acid as well as base, okay, there is a formation of salt and water. Okay, so this is the simple concept regarding with amphoteric oxides of metal. Now let's take one example, okay. I am going to take one metal that will react with acid as well as base, and we are going to find out really is there any formation of salt and water. Let's find out, okay. If zinc oxide, metal oxide, zinc oxide is nothing but what? Here we are going to take that example, zinc oxide. When metal oxides react with acid and base, there is a formation of salt and water, okay. That reaction is known as amphoteric nature or amphoteric oxides of metals. Here zinc oxide will react with HCl. HCl is what? Aqueous. Let me write aqueous. Aqueous means what? It is dilute in nature, okay. It is not in the concentrated form. It is dilute in nature. So what actually happens when zinc oxide reacts with hydrochloric acid? There is a formation of zinc chloride, ZnCl2, okay. Aqueous, plus along with that there is a formation of water. So here metal oxide, this is a metal oxide, zinc oxide, when it reacts with dilute acid, there is a formation, this is salt everybody, and along with that you can find out the byproduct which is water. Now this is one example. What will happen if metal oxide reacts with base? We are going to find out that also. Let's take similar example, zinc oxide, okay. Here I will write it as solid, okay, for your kind information. So this is the proper way of writing any reaction, okay. So when zinc oxide reacts with base, here I am going to take the strong base NaOH, sodium hydroxide. What is the product over here? Everybody, the product will be Na2ZnO2. So this is also the salt, okay. Along with that there is a formation of water. So yes, amphoteric oxide means what? Metal oxide can react with acid as well as base, and yes, in both reaction, in both when reactants, Okay, whether it is acid in nature, whether it is base in nature, you will get what? Salt along with water. So yes, these are the chemical properties of metals, everybody. We have discussed about displacement reaction. We have discussed about the reaction of metals. I have given you various examples what actually happen when metals react with air or oxygen, right? Basic oxides of metal, when metal oxide reacts with when metal oxides dissolve in water, there is a formation of what? There is a formation of alkali. Alkali means what? Base. Okay, that reaction is known as basic oxides of metals. In this way, metal oxides can convert into the alkali, right? Amphoteric oxides of metals, we have discussed it. What is amphoteric oxides of metal? Here, metal oxides can react with acid as well as base, and there is a formation of what? There is a formation of salt and water. So yes, these are the chemical properties of metals. Students, till now we have discussed about what are the physical properties of metal, what are the physical properties of non-metals, what are the chemical properties of metals. Is it easy? Yes, definitely easy. I am explaining in a basic language, so that you will find it out very easy to learn. And yes, everybody, the concept is very easy over here. What are the important points that we have discussed? I have told you that what kind of questions will be asked in your exam on this topic, right? So the first question was differentiate between the metals and non-metals. Now you can see over here, you will be asked like write short note on chemical properties of metals. So yes, these kind of questions will be asked on this topic. Now moving on to the next part, everybody. I am hoping that you are understanding all the concept. Okay, moving on to the next point, everybody. Yes, one of the important point, reactivity series. What is reactivity series, everybody? Basically, reactivity series is the order, is the sequence of the reactivity of metals from highest position to the lowest. Okay, in this way you can assume that what is the product, what will be the product in displacement, single displacement reaction. With the help of this reactivity series, we can find out what we are going to find out. We are going to find out what will be the product in single displacement reaction. Okay, so for that purpose we use reactivity series, because we have learned that, right, what is displacement reaction. In displacement reaction, more reactive metal displaces less reactive metal. Okay, so okay, let me disclose what is the reactivity series over here. Students, for your kind information, yes, let me explain you first this. Okay, and then I am going to tell you one of the important point. Okay, as you can see over here, it is the decreasing order of reactivity. Means potassium is the most reactive metal than gold, silver, copper, lead, iron, zinc, where gold, silver and copper are the least reactive metals. Okay, and they can generally found into free state. So this is the reactivity order. What will happen if potassium and sodium are involved in any one reaction? Definitely, potassium will displace sodium from its aqueous solution. Why this is so? Because the reactivity order of potassium is more than what? Than sodium. What will happen if sodium and gold involved in same reaction? Obviously, sodium replaces gold from its aqueous solution. Why this is so? Because gold, silver, copper, these are least reactive elements. These are least reactive elements or least reactive metals. Okay, so the reactivity order of these metals like copper, silver and gold, that is very low. And yes, platinum also. So we cannot we don't take tension, gold, silver, platinum, you know that. Why? Because these metals are very expensive, but yes, they don't show any reactivity. Okay, because they have least reactivity order. So yes, the main purpose of reactivity series to get to form the product, okay, to produce the product, to form the product in the displacement reaction. So that's why reactivity series is very important. So we have discussed about the reactivity series of metals. We have discussed about the chemical properties of the metals. What is the next point? Okay, now let's discuss about the next point, which is one of the important point. Yes, here one question, student, can metals react with acid or base? Can metal react with water or steam? We are going to find out the answer for these questions over here. Basically, you know that metals are more reactive than non-metals. That's why we are studying the chemical properties of metals. That's why we are studying the reactions of metals with various substances. Okay, so don't get confused why there is not why there is no any reaction with non-metals. Basically, metals are more reactive than non-metals. That's why we are going to see about the various reaction in which metals are involved, not the non-metals. Okay, so here is the first reaction of metals with water or steam. So here two different things are involved. Reaction of water is different. Okay, reaction of metal with water is different, and reaction of metal with steam is different. You have to understand the difference. Okay, if metal, as you can see over here, if metal reacts with water, there is a formation of metal hydroxide, or there is a formation of metal oxide. Along with that, hydrogen and heat is also liberated into that particular reaction. Means when metal reacts with water, there is a formation of metal hydroxide, or when metal reacts with steam is the form of water, you know that. So basically, when metal reacts with steam, there is a formation of metal oxide. Along with that, hydrogen is the byproduct in this particular reaction. Okay, let's take one example. I am going to give you both the example. First of all, reaction of metal with water, and second we are going to discuss about reaction of metal with steam. Okay, so here is the first example for you everybody. We are going to take the easiest metal, sodium Na plus 2H2O. When metal reacts with water, so it is, I will write cold over here for your understanding, so that you can understand that this is the water. If it is in the hot form, that means the state is steam or a gaseous state. Okay, so here we are going to discuss first when metal reacts with water. And yes, there is a formation of what? There is a formation of metal hydroxide. So here we are going to get 2NaOH, which is nothing but what? Sodium hydroxide, metal hydroxide everybody. This is metal hydroxide. Okay, what is the name? Sodium hydroxide. Along with that, what I have said? Yes, along with that, hydrogen plus heat. It also evolved in this particular equation, reaction. So yes, when metals react with water, there is a formation of hydroxide, metal hydroxide. Along with that, there is a formation of hydrogen, as well as heat is liberated, heat is given out, okay, in this particular reaction. Now let's talk about the second reaction. Again, I am going to take the next example for your understanding. What will happen if metal reacts with steam? Okay, we are going to find out the product over here. If metal like zinc, okay, reacts with again water, but this time it is not water, it is steam over here. As I have told you, steam is the form of water, right? So definitely metal reacts with steam means what? But obvious, metal reacts with water. But what is the condition? Condition is hot over there. Cold versus hot. If it is hot, that means it is gaseous in nature, that is steam. Okay, now what will happen? There is a formation of metal oxide everybody. So here there is a formation of zinc oxide. Along with that, there is a formation of hydrogen. Okay, so this is the simple reaction. I have given you one equation form. From that you can understand the reaction easily. Simple is that when metal react with water, there is a formation of metal hydroxide. Along with that we will get hydrogen and heat. Heat is liberated, heat is given out in that equation, in that reaction. What will happen if metal reacts with water? There is a formation of zinc oxide. Along with that you will get hydrogen. Is it simple, everybody? Yes, obviously it is very simple. So yes, in this way you can easily remember, okay, by using this equation, by using this equation form, you can easily remember what will be the product if metal reacts with water, what will be the product if metal reacts with steam. Moving on to the next point, what will happen if metal reacts with acid, everybody? Let's find out. Yeah, on your screen, metals which are more reactive than hydrogen displaces hydrogen from its aqueous or dilute acids and produce respective metal salts and hydrogen gas. So basically when the metal which is going to react with the dilute acid, not the concentrated one, okay, it will be reacted with the dilute form. Okay, basically you know that acid contains what? In acid hydrogen ions are present, H plus ions are present. So if metal is more reactive than that hydrogen, it will displace it from its dilute acid and there is a formation of metal salt along with hydrogen gas. So let me create one easy equation for you. From that you can easily understand how to remember the reaction of metal with acid. Okay, that will be easy for you. So let me write for you. When metal react with dilute acid, there is a formation of, everybody, metal salt, or we can easily write it as salt, and yes, H2 gas, hydrogen gas. So this symbol represent it is gaseous in nature. Okay, again we have to take example for that. Let me give you one example. 2K potassium when react with dilute H2SO4. H2SO4, can you tell me the name of H2SO4, everybody? H2SO4 that you have studied in standard 7. H2SO4 is dilute sulfuric acid, because we are going to use the dilute form, not the concentrated form for this reaction. Okay, so it is dilute form, it is mixed with water, it is in the aqueous form. So there is a formation of what? Salt, and along with that there is a formation of hydrogen gas. So K2SO4 plus H2. Yes, this is the simple reaction. You have to remember just this thing. When metal reacts with dilute acid, there is a formation of salt, along with that there is a formation of hydrogen gas. So yes, potassium when reacts with dilute sulfuric acid, there is a formation of salt. This is salt, K2SO4, potassium sulfate. Okay, along with that we will get hydrogen gas. Is it easy? Yes, definitely easy. Let me give you one of the simple example for your understanding. Okay, what will happen if sodium metal reacts with dilute H2HCl, hydrochloric acid? Okay, so again it is dilute, there is a formation of NaCl, along with that hydrogen gas. Is it easy? Yes, again you have to focus on that equation. When metal plus dilute acid, you will get what? Salt, along with that hydrogen gas. Here what will happen if metal is less reactive than hydrogen? Because you now know that if metal is more reactive than hydrogen, then it will displace that hydrogen from its dilute acidic form, right? And it will form salt and hydrogen. But what actually happen if metals are not that much reactive than hydrogen? Definitely it will not react, it will not displaces hydrogen from a dilute solution if metal is less reactive than hydrogen, and there will be no any reaction, right? So you cannot observe any reaction over there. So in this way you can observe, you can see everybody, when metals, if it is more reactive, then and then only it will form salt along with water, hydrogen gas, not water, everybody. So yes, these are two examples. You can find out from these examples how metals show reaction with acid. Now we have studied the reaction of metals with acid. Let's find out the reaction of metals with base. Moving on to the next point, which is also very important. Can metal react with base? Yes, definitely they can react with base. Let's see. Yes. Again, we have discussed when metal reacts with acid, there is a formation of salt and hydrogen. Again, in basic condition, if base will react with metal, again there is a formation of salt and hydrogen. So both the reaction are actually same, because in both cases you will get salt along with hydrogen. So these two reactions are very easy to remember, right? So yes, we are going to take one example for base plus metal and we will get salt and hydrogen. So here I am going to take one base 2NaOH for you to understand the concept, which is in the aqueous form, and along with that zinc metal is going to react. What will happen if metal, this is metal, zinc is metal over here, when it reacts with base? So there is a formation of salt and hydrogen. So what kind of salt over here? Na2. Is it easy? Oh, thank you, Jay. I hope you are going to enjoy my whole session, and thank you. Thank you so much. Reactions are very easy, right? Very good, very good. Now Na2, as you can see over here, Na2ZnO2. Okay. So yes, Na2ZnO2, here this is the salt. Along with that you will get hydrogen. So what is the name of this salt? It is sodium zincoate. The name of this salt is because that salt looks like very difficult, right? What is the name of that salt? So don't worry, sodium zincoate is the name of that salt. Is it easy? Yes, it is easy. When basically metal reacts with base, there is a formation of salt along with that hydrogen. So we have discussed about the three things. First one, when metal reacts with water or steam, when metal reacts with acid, when metal reacts with bases. So we have discussed more about what are the chemical properties of metal. We have learned about what are the reactions of metal with water, steam, acid and bases. We have studied about the reactivity series. Why reactivity series is very important, everybody? Because in displacement, in single displacement reaction, we will use that reactivity series to find out what is the product over there. Okay. So yes, we have discussed lots of things in this particular session. Moving on to the next point, one of the important point, and this question will be asked definitely for your exam. Okay. Yeah, how do metals and non-metals react? Is it so, can metals react with non-metals? Yes, definitely metals can react with non-metals. See what will happen over there. Yeah, so as you can see on your screen, metals lose valence electron, that we have studied earlier, right? Metal loses electrons to gain or to form cations. So same thing is going to, we are going to use over here, and non-metals gain those electrons in their valence shell and form anions. Basically, students, when metals and non-metals react, that means in easy language, cations and anions are attracted with each other, are attracted towards each other. Okay, and there is a formation of ionic bond, and that bond is held by one of the strongest force, which is electrostatic force. And in this way, there is a formation of compounds. Let's take one example to understand this concept. Okay, in a simple language, remember that cations and anions are attracted towards each other, and there is a formation of ionic bond over there, and that bond is held by which force? Electrostatic force. And in this way only metals and non-metals react with each other. Let's take one example. Okay, hi Siddharth, thank you for joining my live session. I hope you are getting more information regarding with metals and non-metals. Okay, moving on to the next point. Let's take one example, calcium chloride, everybody. Okay, here calcium contains cations, positive ions, and chloride ion, here two chloride ions are there. Okay, remember this point. Here two chloride ions are there and they contains anions. Cations and anions, there is a attraction. Okay, and yes, there is a attraction and there is a formation of what? Strong ionic bond. Now let's discuss about it. We have taken one example, calcium chloride. Okay, let me clear this and then I will explain to you. Calcium chloride. Here, what is the atomic number of calcium? That is 20. And what is the atomic number of chlorine? Here we are going to discuss. Here we are going to discuss about chlorine, and what is the atomic number of chlorine over here? That is 17. Now let's distribute and let's distribute the atomic number into the electrons. So you know that 2882. Okay, and for what is the electronic configuration for chlorine atom? We are going to focus on only one chlorine atom. Okay, so 17 is there, right? So what is the electronic configuration over here? 287. Now you know that here calcium atom contains 2 valence electron in its outermost orbit, where one chlorine atom contains 7 electrons in its outermost orbit. So what actually happen here? Here calcium donate 1 electron to gain or to form positive ion, which is cation. Okay, so it donate 1 electron to 1 chlorine atom. In this way, here are 2 chlorine atoms, right everybody, and calcium has 2 electrons in its outermost orbit. So again it will donate another 1 electron to the second chlorine atom. So in this way, okay, there is a formation of ionic bond between them, and yes, in this way metals and non-metals react with each other. So I hope in easy language you understood how metals react with non-metals, right? Now let's talk about the next point. Yes, now we are going to focus on the next point. The last point of this live video session, applications of metal and non-metals. Student, one of the important point from this topic is remain, which is extraction of metals. If you want video on that particular content, because that content is very important, if you want video on that, please don't forget to comment in the comment section. Okay, and I will make sure that I will prepare one video, one informative video on that. Okay, what are the applications of metals and non-metals? Let's find out fatafat what are the applications of metals and non-metals. Let me disclose, because this is the last point. I hope in whole video session you have learned about lots of important things regarding with this metal and non-metals. So here zinc, which is a metal which is used to protect the iron from rusting, gold and silver that are also the metals that are used for making jewelry, which is the most common use of metal, right? Oxygen is used by plants and animals. You know that oxygen is a non-metal which is very important for all living things, right? For the preparation of ammonia, which is a fertilizer, nitrogen is used. For the purification of water, chlorine is used. Diamonds, you know that diamonds, which is the form of carbon is non-metal. Okay, so diamonds are used for cutting glass in different industries. Okay, so in this way, one student have asked me what is electron. Okay, basically atom contains 3 subatomic particles. What are these 3 subatomic particles? Protons, neutrons and electrons. Protons are the positive subatomic particles of any atom. Electrons, which are negative subatomic particles of any element, and neutrons, which are having no charge. Neutrons are neutral in nature. I hope you will get your answer. Thank you, and I hope you have enjoyed all my video session. If you want more informative video on this topic, please don't forget to comment in the comment section. Student, last but not the least, if you are new to our channel, don't forget to subscribe our channel, and yes, don't forget to press bell icon for more notification. Thank you. Keep study, keep home, stay home, stay safe. Thank you.